All right, welcome everyone to Black Hat Briefings. This is the Turbo Talk. It's a 20-minute session. This is Tyler Close. He's going to be talking about shatterproofing Windows.
Hi there, I'm Tyler Close. I'm a visiting scientist at HP Labs in Palo Alto, and I work in a group called the Virus Safe Computing Initiative. And I'll get to what safe means a little later. So one of the first outputs of our group is a product called Polaris for Windows. And the first four letters of that name, Polaris, are POLA, referring to the principle of least authority. So this is a principle for constructing secure software that's related to one you might already know called the principle of least privilege. It's pretty famous in the literature. Now the key difference between these two principles is that they're not supposed to yet. The key difference between these two principles is that when you're talking about the privileges, or the principle of least privilege, you're focused on what permissions a particular agent can get. When you're talking about the principle of least authority, you're talking about not only what permissions a particular agent has, but what permissions it can cause to be executed by talking to other agents. And so you're looking at its own permissions and transitively all the permissions it can cause to be used. And we think that you need to look at system security this way, at access control this way, in order to get a true picture of what agents can actually do within your system. And so this first product, Polaris, is trying to bring the principle of least authority to Windows. So as a concrete example of one of the things we'd like to do is we'd like to have your normal desktop up with your start menu and everything, but have, say, Internet Explorer running on that desktop in a confined user account that doesn't have the authority to read or write any of your files. So in order for that to work on Windows, though, we've got this little problem. Some of you may know about the work on Shatter that was presented at Black Hat a couple of years ago. And so despite the fact that I may have the browser running in a confined user account that only has access to the file system, by sending Windows messages to another application that does have access to the file system, that application does in effect have the authority to read and delete files on my computer. And so solving this problem is key to getting the Polaris software working. And in this presentation, I'm going to dive in deeper as to exactly how we did that and implemented it. So I've got the Shatter exploit presented originally at Black Hat was done by someone named Foon. I've got his exploit code here in a VM compartment. And we're going to start off this presentation by playing with that exploit code. All right. So this utility right here, this is the original Shatter exploit code that was distributed by Foon. You can download it off the internet. Just Google for Shatter. So one of the interesting things this little utility can do is we'll start by enumerating all the windows that this attack tool can see. And you'll see there's all kinds of neat stuff in there. There's my Start Menu button. All right. There's basically all the windows running on the application. And so this attack utility can send any Windows message to any one of those windows that you see listed there. And so effectively has control over this computer to the same degree that I do, the human, logged into the computer, which is a big problem. So we'll start off. One interesting thing we can do here is I'm going to grab some text here and put it on the clipboard. Actually, before we do that, let's grab the window handle for the notepad text area there. All right. And from the attack application, I'm going to post across a paste message. And you can see I can paste text into the window there from this attack application. So I'll delete that. One of the meaner things you can do to it is I can limit the text length on there. So I'm going to take this open edit field in Notepad and reduce it to only 4 characters. And so now when I'm typing in here, 1, 2, 3, oh dear. So you can see I'm modifying the internal state of this program here through this attack utility. And so the consequences of this are really horrific if you think about it. So if I'm surfing the web and I visit a site with an ActiveX control in it, and that ActiveX control is executing on my machine, it could post a mouse click to the start button, go on up to the run command, type in del star.star, and there goes my computer. So we've got a serious problem here we have to work around if we want to be able to confine these applications on the desktop. So here's Microsoft's response to this. This quote here is taken directly from the TechNet Microsoft response to the Shatter paper that was presented at Black Hat. It's pretty self-explanatory. By design, all services within the interactive desktop are peers and can levy requests upon each other. Basically saying that when you're running an application on your desktop, it has full access to everything on your desktop. There's no way to confine it at all, which is really an odd thing to say, because we've got access control lists that we can apply to the process, and we can create entries in our access control list that say, this process or this login session is not allowed to do the following things, or is allowed to do these things. And at the end of the day, that's pretty much irrelevant, because the process can get those authorities by simply messaging other applications that do have the permissions. So here are my takeaway from this is my takeaway from the Shatter attack. There were some extra parts in the original Shatter attack that was presented. He additionally used the WM timer Windows message to cause an application to jump to an arbitrary point of execution in its process space, and he used this to basically take control of the process. Microsoft issued a patch for that particular problem. I don't think that's the most interesting part about Shatter, though. For me, the enduring problem that Shatter presented was the fact that any application can send a Windows message to any other. And so if you think about it, like the del star.star example, there's plenty of dangerous functionality already in our applications. We really don't need to inject additional exploit code. The attacker can make bad things happen just by commanding the existing functionality. So you can get at the Windows post message thing from a variety of attack vectors. You can, of course, do it from an ActiveX control because you've got native code there. There's also an interface to it from a Visual Basic script. So this could come in a word macro virus. And that's the enduring problem that we have to deal with here. So next, I'm going to take a look at the Windows access policy. In the two papers that have been presented at Black Hat on the Shatter attack, some pretty strong claims have been made that this is an unfixable problem in Windows, that this is a showstopper here for security on Windows. And so I'm going to give you an overview here of the Windows access policy to explain why the authors might have made those claims. It turns out it's a false claim, but let's see what led them to that. So if you look at your machine, this is the figure in the top left corner there depicts graphically the layout of the structures in the Windows access policy. Your machine contains one or more Windows stations. So you can think of the Windows station as being an abstraction of the machine. There's one special Windows station, Winstaw 0, which on a PC version of Windows is the only Windows station that's allowed to control the display and the input devices. Each Windows station has one or more desktops in it. And whether you realize it or not, you're actually using multiple desktops every day when you use Windows. The login screen, so when you hit Control-Alt-Delete, you're actually switching desktops there to a different desktop that has the login application on it. You do your login, it dumps you onto what you normally think of as your main desktop. But those are two equally valid desktops. And then within the desktop, we can have multiple windows. And so the first problem we have here is that there are only ACLs on the Windows station and the desktop. There is no ACL associated with a window. In Windows speak, a window is not a securable object. So right away we're into difficult territory here. There's no ACL we can edit to deny access to certain code. But it gets worse than that. A window handle is scoped to the desktop, not the process. It's a really odd thing when you think about it. If you think under Unix, when you open up a file, you get back a handle to that file, and only the process that did the open can use that handle. Well, under Windows, when a process opens up a window and gets back a handle for it, that process, as well as any other process running on the desktop, can make use of that handle. And so if you look at this problem from sort of a language design perspective, we've got a scoping problem in the way we developed our language. When I declare a local variable, it actually has global scope. Any part of the program can get access to my local variables. So in that's the problem. And right away, it's looking pretty scary. We can see why these claims were made. The Microsoft response claimed that if you want to run applications and keep them separated from one another, what you should do is put them on separate desktops. That's actually not going to work very well on its own because a thread can just switch desktops. So if I start up application here, application A on this desktop and application B on this top, thinking that I've separated them so that they cannot message each other, if the application B is hostile, it can simply switch desktops and then start shattering application A. Similarly, with Windows stations, a process can move between Windows stations. The other thing about both of these recommendations is that they're not really useful. They're not really what we want to do. What we want to do is we've got a windowing environment here where we can have multiple windows on a desktop, but we want to give some of the windows less authority than the other. Right? I want to run my Quicken with the authority to edit my finance files, and I don't want Internet Explorer to be able to write to those files. It's got no business in those files. And so none of them really address the problem. And so the situation at this point in the talk is looking pretty bleak. You can see why these strong claims have been made in the past. So I was actually hired at HP to go and take a look at this hard problem. I joined the group, and then my boss, Alan Karp, immediately dropped the most difficult problem in the project on my lap. And so I was supposed to figure out how to block the shatter attack for our Polaris project. And so if you take a look at the paper I submitted to Black Hat, it should be on the CD-ROM. You can see a bunch of the other alternatives that we went through to try and find a way to block the shatter attack. The key difference being is that they're all hugely labor intensive. We got really lucky, and I found this obscure part of the Windows API that actually does a pretty good job of blocking this attack. So Windows has what's called a jobs API. The API is primarily intended to group together processes so that you control when groups of processes get terminated, how long they run for, and how much CPU time they take up, sort of like bookkeeping, things like that. But there is one odd, out of place really, restriction that you can place on these jobs. You can place a series of UI restrictions on processes that are within this job. And within that set of restrictions, there's this really interesting one here that you see in boldface, job object UI limit handles. And what that means is that any process that has been assigned to this job cannot use a handle that is owned by a process that is outside the job. So that's not exactly what we want. What we really wanted was to get real scoping rules so that when I open a handle, only I can use it. But what this means is we could use this if we could identify where the potentially hostile code was or is and put it inside of a job. We can then at least place a restriction on that group of processes so that they can't read the private handles owned by other processes. So the key bits in the code here are done in boldface. We create the job, we put this restriction on the job, and then when we create the process, we create it in the suspended state. So none of the instructions in the executable have run yet, but we've gotten an ID for the thread and a handle to the handle for the process. And so at that point, we can assign the process to the job so that these restrictions now apply to the job, and then we start the application back up. So the code here is actually pretty simple and is easy to apply. So let's see what happens when we apply this to the shatter attack utility. Let's go back into the VMware compartment. I'm going to shut down this instance of shatter, and I'm going to start it back up inside of a job. So the first thing to notice here is that shatter started. That's a good thing. And it's painting its windows. Also a good thing. It looks like it's running normally. And all good signs so far. So let's see what happens when we enumerate the windows this time. Oh, that's interesting. Shatter can only see its own windows. It can't enumerate all of the windows on the desktop anymore. So already we can see that something different is happening here. All right. Well, let's get this handle again. And try doing a shatter on the notepad over there again. 200. Thank you. All right, so I've got that typed in correctly. All right. So we'll try doing, I'll copy some more text here. And I'll try pasting it in again. Oh dear, didn't work. What about this one here? No, it doesn't work either. This one? No, it seems like all the Windows messages don't work. Things are looking pretty good now. So the important things to realize here are that the shatter application started up. it's painting its windows, it's taking my mouse clicks, it's taking my key presses, it's in general running well, it's running like a Windows application. It just can't shatter anymore. We've rendered it harmless. That sounds pretty good. The shatter authors claimed that fixing the shatter problem would, you couldn't fix it without breaking Windows applications, that if you tried to change the API or change anything about the way Windows applications were launched, just Windows applications wouldn't work anymore. But their utility seems to be working just fine after I've blocked this attack. This is hopeful. Let's see what happens when we apply this defense to, well, in the second I'll apply it to more typical user applications like Microsoft Excel and others. There are a couple things that don't work too well. So even when you're using the mainstream parts of the Windows 32 API, you can come across peculiar behavior. When you use an obscure part, there's more peculiar behavior. One really odd thing is that when a process inside of a job tries to paste data, so take data off the clipboard and put it into its own application, it does that using getClipboardData. Well, it's kind of odd in that if you call getClipboardData to paste a bitmap and you're inside a job, it works just fine. If you do it to paste an Excel chart, it works just fine. But if the data on the clipboard happens to be text, it fails. Kind of odd. There's some other small problems like that, corner cases that seem to be bugs in the implementation of jobs. And so one of the things we do in the Polaris project is we go through and try and identify all these little bugs and put in workarounds for them. Our goal being at the end of the day that you get an application that looks exactly like a normal application and works just like a normal application, but isn't vulnerable to these shatter attacks. And so there's a list of them there, and you can see some of the workarounds in our paper, and there are also some other bugs, juicy bugs, that are also talked about in the paper. But for now I'm going to get to the other part, I guess the kicker of this presentation, that this is all working. I'm just applying this to the Windows application. I haven't broken it at all. And so I've given you a couple demos here, but they've actually all been demos within a demo. I'm running PowerPoint right here within Polaris. And so this instance of PowerPoint that I'm using to give this presentation only has the authority to read and write my presentation slides and nothing else on my computer. So if it turned out that there were a Visual Basic script inside of my PowerPoint slides or something, it couldn't attack my computer. I'd be safe from it. And you can see I've been using PowerPoint just normally. It doesn't look like it's been disabled or hindered in any way. So how am I doing on time? All right, so I'm going to go to the conclusions, and then we'll play a little bit with Polaris so you can get a feel of how it works. It actually makes the computer more usable, which is awfully odd for a security product. Normally security means adding more dialogues, making things harder to use. We're going to do the opposite. So the concluding remarks here are that the claims that were made in the two Shatter papers presented at Black Hat were really overblown and exaggerated. Shatter is not a showstopper. We can solve this problem. So where does that leave us? I'm not saying that Windows is now invulnerable. There are certainly holes to exploit. I've enumerated some of them in the paper. There will surely be others. My hope, though, is that I've changed the landscape enough that we're now dealing with different kinds of holes in different places. And the other point I want to make is that a lot of the talks at Black Hat focus on injection attacks and buffer overflow attacks and similar coding errors. And I want to make the point that that's really not where we should be focusing our attention. Look here where I got my security from, by practicing the principle of least authority. So let's say, for example, there were a buffer overflow vulnerability in Microsoft Word, and there were a Visual Basic macro that could exploit that vulnerability. Well, running on out-of-the-box Windows, when that exploit runs, it takes over my user account and has authority over all of my user files. And so you say, oh, buffer overflow attacks are bad. No, really what the problem is a failure to respect POLA. If I were running Microsoft Word in a polarized environment so that it only had access to the file it was currently editing, then when that buffer overflow exploit runs, well, it took over that instance of Word, but the only thing that instance of Word had the authority over was the file that the macro came out of. Not very interesting. Not much was gained by the attack. And so if we can move to a situation like that, where we're severely limiting the benefit that you can get from an attack, we can make virus writing uninteresting. And that's what we mean when we say virus-safe computing. We don't mean detecting viruses, we don't mean stopping viruses. We mean creating a computing environment in which we can work safely even in the presence of viruses. And if we can succeed in doing that, we've won the war, instead of constantly playing on the catch-up side of the war. And so my advice to you is when you're building applications, practice the principle of least authority at every level of your application. Right here, I've come along way late in the game. These Windows applications were already written, but I've been able to apply a polar wrapper to them and gotten really qualitative increases in security. I claim that if you apply this principle at every step of your development, you will achieve revolutionary improvements in the security of your application. So let's go play with Polaris. We've got a demo that we do for it that's got a backstory to it. I'm not going to give you the backstory. I'm just going to run it and give you the punchline, basically. So I'm going to open up killer.xls here. First thing it's going to do is prompt me and say, do you want to get your work done or do you want to be owned? And I'm, of course, going to choose to be owned because I have to do my work. And so there's a whole story that goes along with this spreadsheet. But there's a macro that gets triggered when I click on this button. And that triggers the virus. And it says it's going to delete these files that it found on my desktop. You'll notice it's going to delete. Actually, I'm going to go and close this so it works. It's going to delete my presentation slides. Oops. All right, we've come into a different part of the. Let's try. All right, this is not the way this is supposed to run.
Welcome to Black Hat.
Yeah. I'm going to come into here, grab another file. All right. So you see that shortcut I created up there, it deleted it. I'm not sure. It's asking me to want to destroy more files. But anyways, the thing we can do here is when we start this up normally, we do a double click on it. It doesn't give me the dialog prompting me whether I want to enable macros or not because I've set the security policy to just always enable them because I don't care if they're in there. And this time when I run it, it's listing all the files here that it can see on my computer to delete, and it's an empty list. And so there's nothing for the virus to destroy. And so that's my presentation. I'll take questions. It depends on how it gets invoked. So for instance, when I'm double-clicking on the file on the desktop, what we've done is we've replaced the file name to executable binding. And so right now, it's binding to our executable. XLS, the Excel extension, binds to ours. And then we create the user account and launch up Excel in there and feed it the document. Yes? So that's actually the magic in all of this. So you'll notice I launched the Excel by double-clicking on the icon. And so we intercept that active designation. And we create an account with no authority. And we add to it the authority to edit the file that the user clicked on. So similarly, once you're in Excel, if you click on the File Open dialog, we'll intercept that dialog, catch which file the user clicks on, and after the dialog closes, we'll add to that running instance of Excel the authority to edit the one file that the user selected. And so we're dynamically growing the authorities of the application in response to user active designation.
If the application has a malicious macro, then can't it also file on open dialog and edit?
Yeah, sure, but the file dialog that it opened up would not be ours. So inside of that account, the only files you can see are the files that you've been granted access to so far. So let's say I double-click on the icon. I come up in this account that has authority over one file. If I open up a phony file dialog and ask the user to select a file to edit, there's only going to be one file in that universe because that process doesn't have access to anything else. And if it just makes up a file name and tries to do a file open, Windows Access Control List will say access denied. You haven't been granted access to that file. And so the trick is when you click File Open, we intercept that and open up a File Open dialog that is outside of the process. And so since it's outside the process, any VB macro running inside the process can't get at it. It can't shatter it because we've put that application in a job. And so we can safely intercept the user active designation. And once we've figured out which file the user wants to edit, we add permission to that file to the running instance of Excel.
Got
Questions?
One question over here. No? All right. Oh.
In the back?
Does this system work with application that run system permissions or only user?
Could you repeat that?
Test this system with this method with application that run system permissions, only application that run under user permissions.
Did you
So the
process
user-
is running a system or versus a user?
So the polarized applications are running in newly spawned, severely limited user accounts, and the user is just logged into their normal account.
No. I mean, it's, you run, let's say, for example, firewall application usually runs with system permissions, not with user account permissions.
So we haven't tried to polarize system daemons yet, or services. But yeah.
All right, y'all. Thank you, Tyler.